You wake up, you glance at the window. The sun is already setting, but you swear you just had breakfast a few hours ago. Your body feels off, like your internal clock is fighting itself. Welcome to a world where Earth spins twice as fast. And trust me, it's stranger than you think. The basics: shorter days, bigger problems. If Earth's rotation doubled, a full day would drop from 24 hours to just 12. But this isn't just shorter days. It means sunrise and sunset happen twice as often as they do now. Your circadian rhythm, the internal clock that controls sleep, hunger, and hormone release, evolved around a 24-hour cycle. Cut that in half, and your body doesn't know when to sleep, eat, or wake up. If this happened gradually enough for evolution to catch up, humans might permanently rewire our sleep biology. Shorter sleep cycles, different hormone timing, maybe even a completely different relationship with daylight. The weight loss myth and the real number. Here's where people usually get this wrong. You've probably heard the claim that spinning Earth faster would fling people off the equator into space. That's not how it works. At double rotation speed, centrifugal force at the equator increases roughly fourfold, since it scales with the square of rotational speed. That would make you noticeably lighter at the equator compared to the poles. A strange but real effect. But you wouldn't float away. Gravity doesn't disappear. It just feels weaker. To actually reach weightlessness at the equator, Earth would need to spin around 17 times faster than it does now. So no, doubling the speed won't launch you into orbit, but it would make you feel like you dropped a few pounds just by standing at the equator instead of the poles. Storms get supercharged. Faster rotation doesn't just mess with your body, it transforms the entire climate system. The Coriolis effect, the force responsible for curving winds and ocean currents, gets significantly stronger with faster spin. That means hurricanes and jet streams would supercharge, creating storms that spin faster and hit harder than anything we see today. Ocean currents would shift too. Coriolis-driven ocean gyres would intensify, potentially reshaping global climate zones and monsoon patterns entirely. Coastal cities built around predictable weather patterns could face completely different seasonal threats. Earth's shape slowly changes. Give this faster spin enough time, we're talking geologic timescales, and Earth's shape itself would shift. The planet already bulges slightly at the equator due to rotation. Double the spin, and that equatorial bulge grows more pronounced, gradually reshaping Earth into a flatter, more exaggerated oblate spheroid. It wouldn't happen overnight, but over millions of years, the planet's silhouette from space would visibly change. Life has to keep up. Shorter days compress everything living things depend on. Photosynthesis cycles in plants could shift, potentially altering growth rates across entire ecosystems. Nocturnal and diurnal animals, the ones wired to be active at night or during the day, would need to adapt their behavior patterns much faster than evolution typically allows. Some species might thrive, others might not adjust in time at all. This isn't pure fiction. Here's the twist that changes everything. Earth actually used to spin this fast. Shortly after the moon-forming impact billions of years ago, Earth's days were only around 6 hours long. We're not guessing about this. It's recorded in rhythmite rock layers, sediment bands that preserve evidence of ancient day length like a geological clock. This hypothetical isn't science fiction, it's Earth's actual early history. So why did it slow down? The moon. For billions of years, the moon has been acting like a brake, slowing Earth's rotation through tidal friction. For Earth to speed back up to double its current rotation, that braking effect would need to somehow reverse or vanish completely, which is worth addressing directly, because anyone with a physics background will immediately ask about it. What would it actually take? Realistically, speeding up Earth's rotation today would require an almost incomprehensible amount of energy, something no natural process happening now could produce. There's no plausible scenario where this happens again in Earth's current lifetime, but billions of years ago, it almost did. Earth already lived through a version of this reality, spinning twice, even 3 times, faster than it does now. So the next time your day feels impossibly short, remember, Earth used to spin so fast that a full day and night happened in less time than your average workday. Would you want your days that short again? Or are you glad Earth finally slowed down?